I'm going to discuss the determination of areas between the graphs of functions. All right? Let me make a picture and then we will continue. Okay, so what I've drawn is the graph of two functions, the graph of the function f and the graph of the function g. And I've also cordoned off a region between those two graphs. Okay, the region between the graph of f and the graph of g with respect to x values between a and b. Okay, now what if we wanted to calculate the area of that region between the graphs and between those purple vertical line segments? Okay, let's think about that. Well, we know that we can approximate an area by rectangles. Okay, so you can start by drawing rectangles. And the more rectangles, of course, that you use, the better your approximation will be. And we can see that this is similar to what we would do if we were calculating the area underneath a single function and above the x-axis, right? Now, if we were calculating the area between a function and the x-axis for the height of the rectangle, we would use a function value, right? What would we use for the height of the rectangles for an area as shown in the picture? Can you see that the area wouldn't be f of x for any value of x for any rectangle, and it wouldn't be g of x for any value of x for any of the rectangles, but it would correspond to the difference of the two functions? Okay, so all of that is to say that the area that I am discussing is equal to the following integral. The integral from a to b of the difference between the functions f and g. Okay? So isn't that interesting? So that's how you can calculate the areas between function graphs. All right? Now let's do some examples. Suppose that we wanted to calculate this area. So give me a minute to make a picture. All right, I'd like to calculate the area in that little triangular region. So the area between the graphs of the functions x over 2 and x over 5 with respect to x values between 0 and 2. So thinking about dividing up that area into rectangles like in the last example, can you see that the area of that triangle would equal the integral from 0 to 2 of x over 2 minus x over 5 with respect to x? All right, so let me go ahead and calculate that. So that would give me what? That would give me x squared over 2 times 2 minus x squared over 5 times 2. And I will evaluate that at 2 and 0 and take the difference. So if I evaluate it at 0, I won't get anything. So I only have to evaluate it at 2. So 2 squared over 4 minus 2 squared over 10. So the first one gives 1 minus 4 over 10. So 6/10 or 3/5. All right? Now, I would like you to try to do one. All right, give me a minute to make a picture. All right, so what I've drawn is the graphs of the x squared function and the square root of x. I'd like you to find the area between those two graphs. Okay, so that teardrop shaped region. All right, so pause the video and try to work that out, please. All right, so I'll go ahead and do that. So can you see that we need to determine the points of intersection between the two graphs? So the graphs intersect at the origin and the point 1, 1. So we're going to want to integrate from 0 to 1, and we will put the square root of x first because it's the one on top. The graph defines the top of the region, minus x squared. Okay, so there we go. So now calculating that integral, so you can split it up into 2 pieces and use your formulas for each piece separately, and you will get x to the 3/2 divided by 3/2 for the first one, and x cubed over 3 for the second one. And we'll evaluate it at 1 and at 0. When we evaluate it at 0, we'll get 0, so we really just have to evaluate it at 1. So the first expression gives 2/3. The second expression, the expression we're subtracting from the first expression, is 1/3. So that difference is 1/3. All right.